All right, everybody, this is chapter 6, lesson 6, or section 6, last one of the chapter. This deals with trapezoids. Trapezoids are oddball of quadrilaterals, okay? So lots of different rules here on these. Some kind of come from the parallelogram group that we had earlier, but then they have some really distinct ones. There's also a couple different kinds of trapezoids. So we needed to be able to distinguish between the different types, okay? A trapezoid is a quadrilateral. So if you want to write this stuff down. Okay, it's a quadrilateral, so it's a four-sided figure, and it's going to have one pair of parallel sides. Okay. It also then has a couple other different things that vocab that kind of goes with it to distinguish different parts of a trapezoid. So bases are typically just what it's the top and the bottom. Typically those are going to be the sides that are parallel to each other. Okay, trapezoids can be drawn, 100 different ways. So you're really just looking for that one pair of parallel sides. Okay, base angles are the angles at the intersection of the sides and or the bottom and or the top. So we'll illustrate that in a couple minutes here, okay? Okay. An isosceles trapezoid is going to have a pair of parallel sides similar to what the first definition was, but it's going to have a pair of congruent sides. And we typically work with isosceles trapezoids in most of the stuff that we do, okay? In this box, it says, we can forget about the 6.20. The trapezoid is isosceles if and only if its diagonals are congruent. So here are the diagonals. If the diagonals are congruent, and there's ways to prove that, but if they are congruent, then we could say this. Now this one's going to be congruent to this one, and that's including the whole thing, not just those little parts of it. Okay, if you have that, then you can say that these sides are going to be congruent. That's what makes it isosceles. Okay, remember isosceles means two sides that are congruent. We've learned that through triangles in an earlier chapter. Okay, so in here we'll use this picture to kind of help us a little bit. Here, these, if I have an isosceles triangle and I've got the parallel sides, these are going to be base angles. Okay, and then these are going to be base angles also. So really, I've got pairs of base angles. And in an isosceles trapezoid, these base angles are going to be equal to each other. So let's letter this. Let's call this A, B, C, and D. Okay, so angle A would be equal to angle B, and angle D would be equal to angle C by our base angles. Okay. The other thing that kind of comes from this too is that, is the keys that I ask you guys to keep remembering, that if you've got parallel lines, then you've got transversals, okay? And in this case, you're going to use same side to your angles are going to be supplementary, okay? So a lot of stuff comes from an isosceles trapezoid. So, a bunch of notes that you need to keep for yourself. And just if we want to make sure we understand this, I could say with this last kind of rule that comes from this, I could say that angle A plus angle D equals 1E. And I could say that over on the other side. Okay. All right. But base angles is a big thing. You got to have that down. And then you got parallel sides. You got trapezoid. On a trapezoid, you got transversal stuff that you're going to try to use. Okay. All right. Here we go. So they're telling me I got this PQRS is an isosceles trapezoid. So right off the bat, I'm going to do this. I'm going to show that these guys are equal. Okay. I'm also going to show that these are going to be parallel. That's what the rules are that I got. They're telling me that angle S is 50 degrees. Okay. So now from all that stuff, I should be able to get a bunch of answers to this. Okay. Find the other three angle measures. Well, here's a base, and I kind of maybe forgot that a little bit. This is a base, okay? I'm going to call that the top, and this is a base, and I'm going to call that the bottom, okay? So that the base angles on each base, if it's isosceles, should be congruent. So angle R should also be 50 degrees, okay? All right, and because these lines are parallel, I can get a transversal kind of thing going out of here, and we just talked about this angle and this angle. So P and S, angle P and angle S should be equal to 180. Well, they told me that angle S was 50 degrees. So I can do some substitution there and then solve it for angle P. Angle P is going to be 130. Okay. So if angle P is 130, then this angle Q is a base angle with it. So angle Q should also be 130 because the base angle should be congruent. Okay. So really important rule there. Hopefully it's pretty straightforward. You kind of follow that and understand that. I think we're good there. Okay. Let's just write this down so I got a mess over here. So angle R was equal to 50. We found out that angle P was equal to 130, and then we used the rule saying angle Q should also be 130. Okay. All right. Let me hopefully got that down. Remember, if I'm going too fast, pause it, write stuff down. Let me get rid of this mess here a little bit so we can see. Okay. Now they want me and B to find the value of X. Well, here's X, okay? So now we remember it was isosceles. We said right off the bat that those guys should be equal. So if things are equal, I can set them equal to each other, and that would help me to solve it for X, okay? So I can divide both sides by 3, and X is 4. Okay. Now, and the rule that we had in the box up there also told us that the diagonals are going to be congruent to each other. Okay, so SQ is one of the diagonals, PR is the other. Now, if they're congruent, I should be able to do the same thing. Congruent means equal, so set them equal. Okay, so hopefully you guys are getting the stuff down as we kind of move through the different chapters. If things are congruent, you can set them equal to each other, or some other rules like supplementary, you can set them equal to 180. You just got to read it and follow directions, okay? So I can subtract 1 from both sides, and then I could divide by 7, and I get X is 3. Okay? All right. Okay. So with a trapezoid, we got this thing called a mid-segment. It's kind of like a midpoint. Okay. This picture here, they're showing this side. These sides are parallel. Okay, so they have a trapezoid has to have a pair of parallel sides. Okay, and the mid-segment is MN. Okay, so basically what that's saying is that M is the midpoint of AB. And N is the midpoint of CD. Okay. Do that. Make this official. Okay. So kind of like the midpoint, I would take what AD is, you know, whatever the measurement of the length is, and add it to BC, and then divide that by 2, and that gets me the length of MN. So that's kind of what this theorem is saying. Okay. So we got a couple examples down here. Let's do example 3 first, because that follows the theorem. Okay. So I'm going to take the mid segment, which is Y. I'm going to set it equal to the 2 bases. So 14 and 4, and then divide that by 2. Okay. So I'm going to get Y equals 18 on top divided by 2. I get Y is equal to 9. Okay. And I think you can see that 9 is 5 away from either one. It also then shows that this segment is equal to this segment. This segment is equal to its opposite. Okay. And I kind of have to know that to be able to apply that, because sometimes trapezoids aren't always going to be equal like that. Okay. Well, they will. There's a couple that are kind of funky, but we can make it work. Okay. Now this one's a little bit different. This isn't. I'm going to use the same theorem, but it's set up differently. They're giving me the mid segment. Okay. Now over here, Y was the mid segment, and I set it up taking that formula that we had. But now they're giving me the mid segment. They're only giving me one of the bases, and I still got to divide it by 2. Okay. So we did this kind of way back when we did midpoints. You know, we gave you an endpoint and midpoint. You had to find the other endpoint. Well, it's kind of the same thing, all right? So hopefully you remember how we start solving this. Remember, I'm calling this a fraction. We don't like fractions, so get rid of the fraction. How do we do it? We multiply both sides by the denominator. In this case, 2. All it's doing is making that go away. But over here, I get 18 equals, I get what's on top over here left over, and I'm going to go ahead and subtract 6 from both sides, and I get that the other base is 12. Okay. Now you will see that question again, so we got to make sure that we understand how to use this. It's just taking a formula, sticking stuff where it's supposed to go, and then knowing your math how to solve it. Okay. All right. So a couple examples on how to use that formula. Okay. A kite. A kite is a quadrilateral. Its diagonals are perpendicular, and one diagonal is bisected. Bisected, not bisected, bisected. Okay. And then let's add to that with some of these rules in the box. So I kind of did this first one. Diagonals are going to be perpendicular. So let's show that that's at a right angle. And I hope that, you know, this should kind of ring some bells. Hey, right angles, looks like got a bunch of triangles in there, so I probably might be able to use Pythagorean theorem again. Okay. To find, you know, lengths of sides or lengths of the pieces of the diagonal. Okay. Second theorem, let's make sure we're not using these again. Okay. Second theorem, if a quadrilateral is a kite, then only one pair of opposite angles are going to be congruent. Okay, so one pair of opposite angles are going to be congruent. Typically, it's off of the short diagonal. Hopefully, you guys can tell what those the diagonals are not the same, and the short diagonal will contain the congruent angles. Okay. You also see in this that the sides and kites, those two sides would be congruent, and these two sides would be congruent. Okay, and this is the diagonal that is going to be bisected. Okay, all right. So a bunch of stuff there about a kite. All right. So we're going to find the side lengths of this kite. First off, they've shown that sides are congruent, but remember the diagonals are perpendicular. This diagonal has been bisected. Okay, and that would help us to probably get some of these things. So this is going to be 8. This 12 actually goes with that piece of the diagonal. Okay, this 20 goes with this piece of the diagonal. Because they wanted me to get the sides of the kite, not the pieces of the diagonal. All right. Some of these pictures aren't great. So remember what I said, because the diagonals are perpendicular, I can use Pythagorean theorem. So I can go here to get this. Okay. I can go here, I'll call that x squared. I can go here, and I'll call this y to get this side. Okay. So I'm going to let you guys do your math here to be able to solve for both x and y. And remember, that's also going to get me these guys over here too, because they're congruent. Okay. So I'll let you do that really quick. Okay, so there's where what your two side lengths should be for x and for y. Okay, now that would, this was 14.4, so this was 14.4. This was 22.2, so that's 22.2. And I can't read my writing. I should probably double check this. I'll double check really quick. Can't read my writing on my notes, so I hope that you guys learned how to write better in kindergarten than I did. Wait a second here. Yeah, see, I can't believe that was what it was. It should be 21.5. How I got 22.2. Okay. All right. So last question down here, we got the couple angle measures here of a kite. They're telling me it's a kite, so even though they don't have the diagonals and stuff, I know it's still a kite. But remember, we learned about angles in here. First off, in a quadrilateral, we learned a while ago that if I take the number of sides and subtract 2 and multiply it by 180, and you can use this for any figure, that it would tell me what all the interior angles should add up to. So they should all add up to 360. Okay, so I'm working on that. They give me a couple here. Now remember, in the definitions we had up at top, there's one pair, typically the short side, of angles that are going to be congruent. Okay, so this one up here should be 120. So I've got, between these two, I've got 240. I add the 80 that they also gave me. That gave me 340. I'm sorry, timeout. 320. And let's just call this guy X because they're asking to find the missing angles. Okay, so I know that I found the other one because they're congruent, but now I can do that. So 120, 120 is 240. 240 plus 80 gives me 320. I'm going to go ahead and subtract 320 from both sides, and I get this angle out here should be 40 degrees. Okay. All right. I think that kind of takes us to the end. There's one little funky thing here. We're going to go ahead and use the mid-segment formula. So I've got a mid-segment. It's this. It equals the top plus the bottom, but divided by 2. Okay. So I want to get rid of the fraction. I'm going to go ahead and multiply by 2. Now, when I multiply that by 2, it's like I'm distributing. So I get 4x minus 8. Over here, they're going to go away. I get 3x. Okay. In this case, I want to gather the variables to one side, the constants to the other. So I'm going to cheat here a little bit. I'm going to subtract 3x and add 8 at the same time. So when I subtract 3x, I get x. When I add 8 to the other side, I get 8. Okay. Now, this question you got to be careful of. I solved it for x, and that was kind of a hard problem. And yeah, I'm proud of myself. I did it. But the rest of the question is, find the length of the mid-segment. So that forces me to have to go back and plug that in. Okay. So 2 times x is 16. 16 minus 4 is 12. And let's just, for fun, let's find the other ones. 2 times x on the bottom is going to give me 16. And x on the top is x, so it's 8. Okay. That's a pretty good problem. That would be a good one to put like on a final. Okay. And then just kind of a diagram here for you, kind of now throwing in kites and some other quadrilaterals like the trapezoid and isosceles trapezoids, how they kind of all go together. But you'll notice that these out here are really kind of in their own little group, and they have their own little specific things where these guys share a bunch of different things together. These, still have, parallel side, or the diagonals are perpendicular. Here you got parallel lines. So that forces you to kind of use the transversal stuff like we have been using. Okay. All right. So just a kind of a cool diagram to have. All right. This is something that I'd rather do in class together. So this is part of your packet. If we're giving you a note packet, or I'll just give this to you as a handout. But this is kind of a cool thing to kind of show relationships with the different figures. Okay. All right. So that's kind of leaves us with 6.6. So hopefully, there's a lot of stuff there in that one. Please make sure you're studying. Please make sure that you're asking questions, getting help when you need it. And we'll see you next time.